Okay, so this video is on the Unit 9C handout, which is going to do some more relationships between angles and the arcs that they intercept. Let me make this screen a little bit bigger. Okay, so we've already covered if you have a central angle, whatever its angle measurement is, the arc that it intercepts is going to be the same exact number of degrees. So if the angle is 50 degrees, its intercepted arc is 50 degrees. And we also learned that if you have an inscribed angle, which is an angle whose vertex is on the circle, then whatever the angle measures, if you double it, you get its intercepted arc over here. So if this one was like 50 degrees, this one would be 100 degrees. Okay? Now it turns out if you take this same diagram for the inscribed angle, and let's say you just kind of moved this one so that it just kept kind of moving along the circle until eventually it was a tangent line right here. If you did that, kind of picture that this is gone now, then the y would really go all the way from the red line to the blue line, and the 2y would be this full arc right here. And so that same property holds if you have a circle formed by an angle in a circle formed by a chord and a tangent line. Then the angle that you get between these two, so this angle right here, that angle, if it measures y degrees, then the arc that it carves out, this arc, is 2y degrees. And so that's stated down here. Here you can kind of see it in another direction. The angle here is z degrees, and the arc that the angle intercepts is 2z degrees. And the best way to remember this, I think, is to kind of categorize the type of angles that you're looking at. So if the vertex is at the center of the circle, it's x and x. And if the vertex is on the circle, it's something that gets doubled. It's something that gets doubled, right? So let's use this property in number 1. Okay, so in the problem there are a bunch of arcs. There are a couple, there's a 44 degrees, and there are 2 chords of length 20 here. So let's see. The 44, if I draw the 44 by itself, notice that it's an inscribed angle, so the arc that it carves out, that it intercepts, is going to be twice the 44. So that's going to be 88 degrees. So this angle, this arc right here is 88 degrees going around from here to C, right? So I'll just put the 88 there. Well, angle X is one whose vertex is on the circle. And so that falls into this category right here. Angle is on the circle. Vertex is on the circle. So it's going to be half the arc that it carves out. So since the arc is 88, X is going to be 44 degrees. Okay. Now if we look at this triangle right here, I'll use a different color. If we look at this triangle right here, you can see that the 20 and the 20 are the same. So it's isosceles. Whoops. It's isosceles. So that means that this angle and this angle have to be the same. So if I take the 180, which is up here, 180 and subtract the 44 up there, I'm going to get 136. And then I'll divide it by 2 to get each of those remaining angles. So that's going to be 68 degrees. So this angle is 68. Let me clear this up a little bit. This angle is 68, and this angle is 68. So Z, 68 degrees. Okay, so let's look at Y. So here's Y over here. I'll get another color out. Here's Y, that arc. And if you notice that what carves it out right here is angle Z. If I draw that by itself, here's the circle, here's angle Z, and here's the arc that it carves out right there, y. Now z we already know is actually 68 degrees. And the corner is on the circle, so that's an inscribed angle, corner on the circle. So whatever this is, the angle is, the arc is twice that. So if this is 68, y is 2 times 68, which is going to be 136. All right, let's take a look at the next part. So in this one, notice the angle here that we're looking at is outside the circle. The vertex is outside the circle. Before we covered if it's at the center, then it's the same as the arc. And we figured out that if it's on the circle, I'll use x again, then it's half the arc. Even if it's on the circle where one of them is a tangent, right? This would be 2x. The angle here would be x. So now we're talking about what if it's outside the circle, not in the center and not on the circle, but outside the circle. So the way that I labeled this diagram, notice that if you have an angle outside the circle, it actually doesn't cut out just one arc, which a lot of people think it just cuts out the L. But really, if you kept those lines going, it also intercepts the B. So that you actually have 2 arcs intercepted here. And I labeled them B and L for big arc and little arc. Now you can use whatever letters you want, but I don't know. I just think B and L are kind of intuitive. So big and little arcs. Now this one's a little complicated, but the way to figure out what x is in terms of those 2 arcs is to create a chord in here. So we could either do e to r or g to c. I'll just choose g to c right here. So there's g to c. Now, this angle right there is an inscribed angle. Right? If I draw it by itself, that angle carves out the B. So that means that this angle right here is going to be half of B, right? Because it's half of the arc that it carves out. So I'm just going to label it right here. This is half of B. And then if you look at this angle over here, this angle right here, notice that that's inscribed because it's on the circle, and it carves out angle or arc L. It intercepts L. So if I draw that one by itself, here's L, and this angle would have to be half that size. So this angle is half of L. Okay? So let me label this half L. All right, so let me draw just part of this diagram out. So I'm going to get rid of this for now. And I'm going to trace out some of this. And move it over here. Right there. Now this angle right here is the one called X. Okay, so I know that if I added this angle, the half L, the X, and this angle right here, I should get 180 degrees, right? Well, this angle right here, let me make that a little bit straighter. This angle is 180 minus the angle right next to it, because these two add up to 180. So this angle, I'm going to say, is 180 minus half of B. That's that angle. So what I'm going to do now is add up the 3 angles of the triangle. X plus half of L plus the 180 minus half of B. And I know that's a triangle, so that should all add up to 180. And then the goal is to get X by itself. Well, that's not actually too hard. The 180s cancel. And then if I add a half B to both sides and subtract a half L from both sides, I get 1/2 B minus 1/2 L. Well, if I factor out the half, I get half of the big arc minus the little arc. So here, let me shrink this down. And I'll put it right there. So the main idea here is that if you have an outside angle, realize it cuts out two arcs, a big arc and a little arc. And the property that you're pulling out of this whole thing is that that outside angle equals half of the big arc minus the little arc. Okay? All right. Let's go on to the next problem here. So in the next one, you have another outside angle right here. Right? This angle is outside. And so it actually has the same property as the one above it. It carves out two arcs, a big one and a little one. And the angle, since it's outside the circle, is going to be half of the big arc minus the little arc. Now we'll get to that in part B. In part A, it mentions that these are both tangents, and they're tangent to the circle H. And the question is, why is RE congruent to RN? So it turns out if you have a point outside a circle and you draw the two tangents to the circle, they're always going to be the same length. But we'll prove it. So first I'm going to draw a radius right here. HE and HN. I'll draw two radii. So I know HE is going to be congruent to HN because they're both radii. Right? All the radii have to be congruent. So I'll mark those congruent. And then I know that since it's a radius drawn to tangents, these guys are going to form right angles. Remember that property. It's like the bike wheel and the spoke with the ground here. It has to be perpendicular to the ground. So I know that angle HER and angle HNR are right angles, right? And that's because we've drawn radius to tangent, right? I'll say radius is perpendicular to tangent. Okay. And then I'm going to do one other thing here. I'm going to draw in that segment right there to make two triangles. And I know that that's congruent to itself. HR is congruent to HR because that's reflexive. So you could do a couple different things. One is I've got two right triangles, and I know the hypotenuse in both triangles, and I know one of the legs in both triangles. So I could solve using Pythag for the missing sides. And if you did that, and you knew the numbers for those marked sides, you would have to be plugging in, like if I did a squared plus b squared equals c squared, well, the c is the same for both of them. And if you called the radius a, the radius is the same for both of them, so the b is going to have to be the same for both of them. So you could show, RE is congruent to RN by using Pythag. Or if you prefer kind of first semester stuff, you could say triangle REH is congruent to triangle RNH because of, now it's a right triangle, and I've matched up the hypotenuse and one leg, so because of HL. And so we can say RE is congruent to RN because of CPCTC. Okay? Now, so the main goal, though, the main idea there is if you have a circle and a couple of tangents that you drew to the circle, then these guys are always congruent. Okay? All right. So then the next part says, suppose in the same diagram that EN has a measurement of 140 degrees. So I'm just going to redraw this by itself here. Here's the circle. Here are the tangents. Here's EN. And R is here. And they mentioned that EN is 140 degrees right there. Find this angle, okay? Well, I know that it's an outside angle, so I'm going to be using this rule right here. So I need the big arc minus the little arc divided by 2, cut in half to get angle R. Well, the big arc right here, right, from E to N, but the major arc is going to be 360 minus 140. So that's going to be 220 degrees. So if I did measurement of angle R equals half of the big arc minus the little arc, and what I'm really doing is half of 220 minus 140. So that's going to be half of 80 degrees, which is going to be 40 degrees. So there's my measurement of angle R. Okay? Now, if you wanted to, you could do this another way, but you'd have to draw on all this other stuff. This is 140, so that means that this central angle right here is 140 degrees. Now, you know that you've got a 90 here and a 90 there, so you could either cut it up into a triangle, 2 triangles, and say 70 and 70, and then end up with 20 here and 20 there when you get 180 in the triangle. Or you could say this whole shape is a quadrilateral, and you know 3 of the 4 angles, so then you could solve for the missing one by setting it all to 360, and you would get 40 for the missing angle. Okay? But that requires you to draw in all the extra lines, which is not easier, I think. Okay, so the last problem has you trying to find all these missing angles and arcs. So generally the strategy for these is just fill in everything you can in the diagram first, and then come back and fill in the blanks. So in this one, let's see. We've got a few arcs, almost all the arcs, but not quite. We do have this central angle here of 80. So if that central angle here is 80, then this arc is going to be 80 degrees also, because central angles and their arcs are the same. By the way, I forgot to mention it. S is the center. S is the center of the circle. Okay, so this arc is 80. And then the only arc I'm missing now is KR. So I know KR is going to be 360 minus all the other arcs. So if I do measurement of KR equals 360 minus 120 plus the 34 plus the 75 plus the 80. And if we work that all the way out, let's see, I've got it here somewhere. I'll just tell you what it is. Let me find it. I don't even know what internet I'm on. Hold on a second. It is 51 degrees. So this arc right here is 51 degrees. Okay, so let's see, what else? I know that this is a radius, and this is a radius, so these guys are congruent. So in this triangle right there, I've got 80 degrees here. It's 180 total. So 180 minus 80 is 100. And if I divide by 2, I get 50 and 50. So 50 here, 50 there. What else do I have? I have these 2 angles out here. So I'll look at this one first. So if I look at that one, here, I'll draw it over here. Let's see, it's way outside the circle. This is BYE. And it's an outside angle, so it carves out 2 arcs. The big one over here and the little one over there. And the big arc it carves out is 80, and the little arc it carves out is 34. And I want this angle right now. And so measurement of angle BYE is going to be half of the big arc minus the little arc. So that's half of 56, which is 28 degrees. So this angle is 28 degrees. And then if we did the same thing with this bottom angle right here, so I'll draw that one by itself. Whoops. So let's see. Let me move this over. So if I draw the circle again, and just that bottom part, that's a tangent. Let's see, it carves out two arcs. The big one's 75, the little one is 51. And this is the angle that we're looking for. So that one is EYR. So measurement of angle EYR is going to be half of the big one minus the little one. So that's half of 24, which is going to be 12. So this one is 12. I think at that point, that's just about everything we could possibly find. So let's see if we got everything. BE, arc BE is 80 degrees. RK is the 51 that we solved for. SBE is the 50 right up there. SEB is the other 50 in that triangle. Let's see, BYE. BYE we solved for down here is 28 degrees. And the EYR we solved for right here is 12 degrees. Okay, so I hope that helps some. And I think that's the last problem. Yeah. And I'll see you guys soon.